So welcome to the high energy physics data transfer demonstration using the BELLA network link. In this demonstration, we'll show you how BELLA will support the high energy physics community in the forthcoming years. So just as a reminder, the worldwide LHC computing grid is structured as a set of tiers that include several computing facilities in each tier. So the experiments produce data at a huge data rates, and this data is sent to the tier 0 at CERN. And then we have a set of tier 1s, large tier 1s that have data custody across several countries. There are 14 tier 1s, and then data is distributed to the tier 2s. The tier 2s also provide computing capacity for simulation that is then stored in the tier 1s. So the data transfer between the several tiers is of utmost importance to us. In the demo, we will show the data transfer between LIP and SPRACE. So these are two tier 2s, one in Portugal and another one in Brazil. And we will be using Grid FTP and the worldwide LHC computing grid tools for the data transfer. So Grid FTP is one of the data transfer protocols that is used by the high energy physics community, namely in the worldwide LHC computing grid. And in the demo, we'll discuss the aspects of network data transfer, the bandwidth and latency that affect the data transfer. And then we'll show you the location of data sets. We'll be performing data transfers, and we'll show you the results as measured by our monitoring tools, both at SPRACE and LIP. So let me just give you some words about the LIP setup. At LIP, as it has been previously explained, the tier 2 is in fact hosted at INCD, the Portuguese National Distributed Computing Infrastructure, that provides the computing and data resources to support the tier 2 and other research communities in the country. And for this demo, we set up two servers, BELLA 1 and BELLA 2. With each server has a network interface card with a capacity of 100 gigabits bandwidth, so 100 gigabit Ethernet, and it's connected to a Cisco Nexus switch, both servers, and these servers are then connected through a dedicated link to the Portuguese Academic Research Network, which is FCCN. Actually, the network equipment from FCCN is already hosted within the same data center where the tier 2 is located, which facilitates the network connectivity. And then FCCN is connected to GN, which provides the connectivity to BELLA. So looking at the network latency between LIP and SPRACE before BELLA and after with the dedicated links for BELLA. Previously, we had a 254 millisecond round trip, and you can see here the trace route between our tier 2 and the SPRACE tier 2 in Brazil. And you can see that we had 18 hops in the trace route previously, and now we only have 8 with BELLA, and this provides us a 106 more or less millisecond round trip. And now I give the word to SPRACE.
So, hi. So I'm Rogério from the Center for Scientific Computing at São Paulo State University in São Paulo, Brazil. We also operate tier 2 cluster, which is tied to the CMS collaboration. If you go to the next slide, please. Here we can see a bit of the setup that we have configured for this demo. So we see the SPRACE as a tier 2 center, which is inside the São Paulo State University. We are responsible for the scientific computing data center of the university. So SPRACE is installed inside this data center. We have also prepared 2 servers, sprays 01, sprays 02, tied with inside our infrastructure using 100 gigabit per second network cards. So our setup includes two Huawei switches, one installed in our data center, the C8861, and another one installed at RedNesp. RedNesp is a regional research and education network. The acronym stands for Research and Education Network of São Paulo. So it's more or less 30 kilometers far from our data center. So we have some optical equipment to connect these two switches. For this demo in particular, we connected to RNP, which is the national RNE network, Brazilian RNE network. And so we connected at 100 gigabit per second at the Cisco ASR 9000. And from RNP, we can reach Rede Clara, going from São Paulo to Fortaleza, also in Brazil. And from Fortaleza, we get the Bela link up to Lisbon in Portugal. Our production traffic goes through US. So we go the other side of the picture, going through Amlight, which connects us to Miami in US. And from there to Atlanta and Washington, DC. So we get Internet 2 and SNet, and from there we go up to the Tier 0 center at CERN. So next slide. We see in this diagram, already shown by Sergio before, the difference in latency when we go to Lisbon from São Paulo, going to our production network that we have nowadays, and the new link provided by the Bela link. And we can see the big difference in latency that we can get from this new path, which is quite interesting to us. The next slide. I don't think there's another one. Oh yes, and this is a plot showing the results that we've been getting from almost 1 day and a half before up to today, showing the several transfers using different tools, showing the traffic using the Bela link. So I'm here at Sprays access machine, and I'm starting a trace route to Bela 1, which is in Lisbon. And we see from our production network that we have this 254 milliseconds, starting from our gateway up to the machine in Lisbon. And if I do the same from our machine in our data center, but tied to the Rede Clara, so we're using the new path that we have just established, and we do the same trace route, then we got the value that we shown before, 107, 8, 10. Best result should be 106 milliseconds. So now we see a data transfer demo running in real time. We've started this transfer a few minutes ago, and it's quite stable, going more or less near 100 gigabit per second limit of the link. This transfer is going from Sprace. Data is being generated at Sprace and being sent to Bela in Lisbon. So we see that it's quite stable. The average transfer around 8, 9, or 90 gigabit per second, and we can sustain this traffic for quite a long period, which is a very good result. We consider this a very good result.
So now we'll be demonstrating usage of Grid FTP to transfer files between Sprace and the LIP tier 2 in Lisbon. So we'll be using Grid FTP between the production systems of the tier 2 in Brazil and the tier 2 in Lisbon. And this will enable us to see the current status of data transfer from the production systems using not the Bela cable, but the production connection that in case of Sprace goes through the US as it was before explained. So I will fire a data transfer. We can see that we'll be transferring a 1 gigabyte file from Sprace, from the storage resource management system at Sprace, and we'll be using GFAL, which is a tool used by WLCG to copy files. And we can see here the endpoints for the file transfer in Sprace. So we are using the production systems in both ends, which are SRM systems. And as we can see, we are transferring at 34 megabytes per second. A file with 1 gigabyte size. And we achieved 34 megabits per second, and the transfer is finishing 30 megabytes per second. So about 240 megabits per second for 1 gigabyte file transfer. And now, transferring 2 files. So I will be using 2 windows, each one with a different file transfer. And these files are 40 gigabyte files that are also at servers in Sprace. 2 servers, Sprace 01 and here Sprace 02. And they are being transferred to Lisbon. And at this moment, the file transfer is being set up for this file transfer. So the file transfer started for both file transfers. We are transferring at 578 megabytes per second, and here at 600 megabytes per second. So this is a 40 gigabyte file. In production, we transferred a file with 1 gigabyte. As you can see, the bandwidth is quite constant. And it finished in 94 seconds here and in 96 seconds here. And the file, you can see the file already in the storage system in Lisbon with 40 gigabytes. And the same here. So let's see. We need to wait a bit for the monitoring. And we can see here the aggregated usage of the Bela link for the tier 2. And it's a 10 gigabit per second, a 10 gigabit per second transfer, which is a considerable improvement over the production. So now we'll be demonstrating the transfer of multiple files, not only 2 files in parallel, but a considerable number of files in parallel between Sprace and LIP, and using the same technologies. And I will fire these transfers. We'll be using the SRM storage systems at SPRACE and LIP still, and using GridFTP, but this time with a considerable number of transfers going in parallel of different files. So we'll be transferring between a pair of servers files with a size of 10 gigabytes, and between the other pair we'll be exchanging files also with 10 gigabytes. And as we can see, we are achieving a transfer of a bandwidth of 46 gigabits per second, transferring files from SPRACE to the LIP tier 2.
Hi there, my name is Katie Ellis. I work at the Rutherford Lab in Oxfordshire, United Kingdom, and I'm a member of CMS. Today I'm going to show you how to make a transfer from CERN to SPRACE in Brazil. So firstly, I need to find an appropriate data set to do the test with. And I found this particular block here, which contains 2 files and total size of 1.7 gigabytes. So I'm going to take a copy of that and check using Rusio, which I've already set up. This is our data management tool. And I'm going to look at where this block is placed already. So this is telling me that the 2 files in this block are based at KIT, at CERN, in the US, in Russia, on Fermilab tape, and in Italy. So now I'm going to place the rule which will move the data from CERN to SPRACE. Here I'm specifying the site in the CMS site naming convention. And now I'm going to specify the source. Which is CERN. This should be all we need to create the rule. And now it's been successfully created. I'm gonna check that it all looks good. So check the rule info. And there it is. So it's in the replicating status. That's good news. Now I'm going to look at the names of the files that we've just asked to be copied. Here are the 2 names of the files. They are root files. And I'm going to use this full name to search in the Kibana monitoring and see whether our file has been submitted. And I can see that it has been submitted. You can see the destination RSE is SPRACE. If I make this a little bit bigger, maybe it's easier to see. So you can see there are 2 elements here. The first one was the queued transfer. The second one was the submitted transfer. And we'll come back in a little while to see the transfer being made. And we're back, and I can see that the transfer, which was submitted earlier between CERN and SPRACE, is complete. Here it says transfer done. And we can check in Rusio that this has been completed. And indeed, you can see that the rule is now in an okay state, and I would expect to find those 2 files on the disk at SPRACE.